A mirror waits in silence. A face leans closer. The image it holds is familiar, yet reversed. Right becomes left, and left becomes right. What appears whole is, in truth, divided two versions of the same being, separated by a sheet of glass. One real, one reflection, both existing, yet never touching. Now stretch this image beyond the human scale, beyond the room, beyond Earth. Imagine the universe itself pressing against an invisible mirror, stars burning, galaxies spiraling, the ticking of time itself reflected in a parallel world, a cosmos that looks like ours, but reversed in its very fabric. This is the essence of the mirror world hypothesis, a radical idea born from the mathematics of symmetry. It whispers that our universe may not be alone, that it is only half of a grander balance, the visible side of a deeper reality, that when the Big Bang ignited creation, it did so twice birthing, not one universe, but two, one made of matter, the other perhaps of antimatter, one flowing forward in time, the other receding backward. Together, they balance the equation of existence, like two dancers moving in perfect opposition. If this is true, the cosmos we know is only a shadow. Every atom, every star, every breath of life paired with a hidden twin that moves in reverse, invisible yet inseparable. So the questions linger, haunting and unresolved. Are we the reflection of another universe? Or is that universe the reflection of us? Chapter 1: Discovery Phase. At the dawn of the 20th century, a quiet revolution stirred within physics. The old certainties of Newtonian mechanics, so long the trusted map of the universe, were beginning to show cracks. But within those cracks, something more profound revealed itself, a hidden architecture of nature, carved not in matter itself, but in the symmetries that governed it. Symmetry, in its simplest form, is the language of balance, a face reflected in a mirror, a snowflake divided along its crystalline arms, a circle unbroken by rotation. To the human eye, symmetry has always carried beauty, a kind of natural perfection. Yet in the hands of mathematicians and physicists, it became something more. It became law. The realization crystallized in 1918 when the German mathematician Emmy Noether uncovered a truth so profound that Albert Einstein himself called it a revelation. She showed that every conservation law in physics, every preserved quantity, was the shadow of a deeper symmetry. Time translation symmetry guaranteed the conservation of energy. Space translation symmetry ensured momentum would never vanish. Rotation symmetry preserved angular momentum. In Noether's theorem, physics gained a Rosetta Stone. The laws of preservation were nothing less than the footprints of symmetry itself. From that moment, symmetry became more than elegance. It became the skeletal frame upon which the laws of reality were built. To break a symmetry was to break the conservation laws that held the cosmos together. And so, physicists assumed nature must protect her symmetries at all costs. Through the first half of the 20th century, this faith seemed justified. The electromagnetic force respected symmetry. The strong nuclear force obeyed it. Even the newly uncovered quantum laws, strange and counterintuitive as they were, still bent the knee to symmetry's order. Among these symmetries was paritize, the idea that the laws of physics should remain unchanged if left and right were reversed, as in a mirror. In the mathematics of particle physics, parity was as sacred as any law. Why should nature favor left or right? To choose one would be to violate the neutrality of reality itself. Parity was taken as an absolute. But nature, it turned out, had been hiding her secrets behind a one-way mirror. In 1956, two young physicists Tsung-Dao Lee and Chien-Shiung Yang raised an unsettling question. They studied the weak nuclear force, the elusive interaction responsible for radioactive decay. Unlike the strong and electromagnetic forces, the weak force had remained mysterious, poorly understood, its mathematics incomplete. Lee and Yang suspected something radical. Perhaps parity conservation had never been tested in weak interactions at all. Perhaps the mirror law of left and right symmetry was not universal. It was a bold suggestion. To many physicists, it bordered on heresy. Parity conservation was a cornerstone of physics. To doubt it was to question the symmetry of reality itself. Yet Lee and Yang pressed forward, urging experimentalists to test the claim. The challenge fell to Chien-Shiung Wu, a Chinese-American physicist whose mastery of experimental precision had earned her international respect. In the winter of 1957, in a laboratory cooled by liquid helium, Wu aligned the nuclei of cobalt-60 atoms and watched as they decayed, emitting streams of electrons. If parity held true, the electrons should emerge symmetrically, indifferent to left or right. But the electrons betrayed the theory. They spilled preferentially in one direction, as though the weak force itself carried a handedness, a bias etched into the very laws of decay. Parity, conservation, long assumed unbreakable, had collapsed. The revelation sent shockwaves through physics. The mirror of the universe had cracked. The weak force chose left over right, as if the cosmos itself had a dominant hand. For the first time, physicists faced a troubling question. If one of nature's most sacred symmetries could fail, what did that say about the others? Was symmetry truly fundamental, or only an illusion that crumbled under deeper scrutiny? And yet, in the ruins of parity's fall, a more tantalizing idea began to take shape. Perhaps the symmetry was not destroyed at all. Perhaps it had only shifted into a hidden place. What if the mirror was not gone, but concealed, reflected, in a realm beyond the reach of ordinary detection? This speculation gave birth to one of the most haunting concepts in modern physics, the idea of a mirror world. In the Soviet Union, where the Cold War drove science into fevered competition, theorists began to imagine a parallel sector of matter. Physicists such as Andrei Korov, who would later be celebrated for his visions of cosmology and human rights, and Lev Okun, a pioneer in high-energy theory, asked whether parity might still hold true not in this universe alone, but across. 2. What if every particle had a mirror twin, a mirror electron, a mirror proton, a mirror neutron? Entire atoms, stars, and galaxies could exist, not in metaphor, but in parallel reality. A universe of matter invisible to our instruments, because its particles interacted only with themselves, reflecting ours in silent isolation. The symmetry, then, would be restored at a higher level, not in our visible cosmos, but in the union of both worlds together. Our universe would be only half of a larger whole. At first, such ideas seemed speculative, even fanciful. Yet the timing was uncanny, for in these same years, astronomy was revealing another riddle. galaxies were spinning too fast. The stars at their edges were moving as if pulled by hidden mass matter that emitted no light, no heat, no detectable radiation. Dark matter had entered the lexicon of physics, though no one knew its identity. Could the mirror world, some wondered, provide the answer? Could the invisible gravitational weight of galaxies belong not to exotic particles of unfamiliar kind, but to mirror matter itself, stars and planets that shine only in their own hidden light? Though unproven, the speculation electrified the imagination. The seeds of the mirror world hypothesis had been planted, and not by philosophers or dreamers, but by the cold precision of experiment. Was no mere curiosity. It was the crack in the glass through which scientists glimpsed the possibility of another realm. A symmetry, once thought absolute, had fractured, and through its fracture came vision, a reflection of the universe itself, concealed beyond observation, waiting in the silence of hidden law. The idea has never fully left physics. For every symmetry broken, there lingers the question, is it gone, or has it only been hidden from view? And if hidden, where does it lie? Thus began the long and mysterious journey of the mirror world hypothesis, a journey born not in the philosophy of the abstract, but in the hands of scientists watching electrons spill in one direction and daring to imagine an entire universe spilling in the other. Chapter 2: Scientific Shock. In science, the most unsettling discoveries are not those that add a detail to the map of knowledge, but those that redraw its borders. For centuries, physics rested on the conviction that symmetry was the language of the cosmos. Symmetry in form, symmetry in motion, symmetry in the equations that described the dance of particles and planets alike. It was more than elegance. It was necessity. Symmetry meant that the laws of nature did not favor leftover, right? Or matter over antimatter, or one corner of the universe over another. It was the quiet assurance that reality was fair, balanced, and predictable. But then came the break. In 1956, theoretical physicists Tsung-Dao Lee and Chen-Ning Yang dared to question what others had taken as absolute. They suggested that the weak nuclear force, one of the four fundamental forces of nature, might not obey mirror symmetry. It was a radical suspicion, and it was met with disbelief. How could nature, so precise in its order, commit such an asymmetry? The experiment fell to Chien-Shiung Wu, who designed a test with cobalt-60 atoms, cooled to near absolute zero. Her results were unequivocal. When these atoms decayed, the electrons they emitted betrayed a preference for one direction over its mirror image. The sacred mirror had shattered. Physics reeled. If symmetry could fall in the weak force, then the universe was no longer the perfectly balanced stage it had been imagined to be. The philosophical wound was deep. The laws of nature, once thought to be universally fair, seemed to play favorites. The universe had chosen a handedness, and in doing so, it had broken an ancient covenant with the human mind. From this fracture rose a daring thought. Perhaps symmetry was not broken at all, but hidden. Perhaps, beyond the veil of the observable, another world existed. A mirror world, where every particle had its counterpart, every force its twin, every imbalance its correction. Together, the two universes would restore the symmetry that seemed lost hours, incomplete on its own, would find its reflection in a hidden realm. Mathematics did not resist this vision. The equations of quantum field theory allowed for the existence of mirror particles, duplicates of the known ones, identical in mass but reversed in their handedness. They would interact with one another, forming their own atoms, their own chemistry, their own invisible cosmos. To us, they would be almost undetectable, ghostly presences interacting only through gravity, slipping through our detectors like shadows through glass, that the implications rippled outward with staggering force. Astronomers had long known that galaxies spun too fast for their visible stars alone to hold them together. Something unseen, dark matter, was providing the extra gravity. Could mirror matter be that hidden scaffolding of the universe? Could the galaxies we see be only the luminous embroidery on a vast and invisible tapestry of mirrored stars, mirrored planets, even mirrored life? The possibility grew more haunting when physicists turned to the puzzle of antimatter. In the early universe, matter and antimatter should have been born in equal measure. Each particle should have had its mirror opposite, annihilating one another, until nothing but light remained. Yet the universe today is dominated by matter. Where did the antimatter go? Why did the balance tip? Some theorists suggested that a mirror sector could tip the scales by siphoning away interactions, by existing as the silent partner in the cosmic equation. The hidden world might have given matter the slight advantage it needed to survive. Without it, there would be no stars, no planets, no beings to ask these questions. And yet, skepticism endured. For if such a universe exists, where is the evidence? The mirror does not shine, it does not emit light, it does not leave fingerprints in the electromagnetic spectrum. Detectors built to catch the faintest whispers of dark matter have remained silent. The mirror, if it exists, is a master of concealment. To many, it seemed too extravagant, too speculative, a patch sewn onto the torn fabric of symmetry. But to others, it was precisely the kind of daring vision that physics requires. For the laws of nature do not forbid it. There is nothing in the mathematics of quantum fields or general relativity that says a mirror sector cannot exist. And in science, what is not forbidden is often possible. Thus, the mirror universe lingers as a haunting possibility, a silent twin to our own, perhaps touching us only through the pull of gravity, perhaps shaping the cosmos in ways too subtle for us to yet perceive, a doubled reality hiding in plain sight. The shock was not merely scientific, it was existential. If our universe is not the whole, but only half of a grander structure, then everything known is provisional, incomplete. The cosmos, far from being a finished portrait, may be only one side of a greater canvas, a painting waiting for its reflection. And so the question remains, is symmetry truly broken? Or is it merely concealed behind a mirror too perfect for our eyes to see? Chapter 3: Deeper Investigation. By the 1970s, the universe had become a puzzle of absences. Astronomy and particle physics, though separated by vast scales, were both confronting the same shadow. The sense that reality was incomplete. The equations worked, but the cosmos itself whispered of something unseen. Theorists began to imagine a hidden sector, a parallel scaffolding of matter that mirrored our own. Mirror particles. They called them twins to the known particles, the electron, the proton, the neutron, but bound together in their own self-contained world. They would share the same mass, the same rules, the same capacity for structure. And yet, Unlike the particles of our familiar realm, they would refuse to mingle with ordinary matter, interacting only through the weakest threads, gravity, or perhaps through rare portals that flicker between the two worlds. This vision was not fantasy. It was a natural extension of physics' deepest language, the equations of symmetry. If the weak force had broken the mirror, perhaps a hidden sector restored it, keeping the universe balanced on scales too vast for direct perception. The hints began to gather, subtle as starlight at dawn. Astronomers had already measured galaxies, spinning too quickly for their visible stars alone. Clusters of galaxies bent light in gravitational arcs, their mass far exceeding what telescopes could see. Dark matter had become unavoidable. Could mirror matter be its face? A cosmic population, invisible but gravitationally indispensable, binding the universe together in silence. The cosmic microwave background, the afterglow of the Big Bang, added its own voice to the mystery. When mapped in exquisite detail by satellites like COBE, WMAP, and later Planck, it revealed a universe of astonishing symmetry on the largest scales. Tiny fluctuations, seeds of galaxies yet to form, were spread evenly across the sky, as though imprinted by an underlying order that extended beyond what ordinary matter could account for. The pattern whispered of hidden contributions, unseen participants in the cosmic symphony. Meanwhile, particle physics faced anomalies of its own. Neutrinos, those ghost-like particles born in nuclear reactions, refused to behave as expected. They oscillated between flavors, electron, muon, tau, changing identity as they traveled through space. But experiments suggested that something more was happening, something unaccounted for. Hints arose of sterile neutrinos, particles that did not interact through any known force. Some physicists proposed they might in fact be messengers from the mirror sector, slipping between worlds, vanishing from one side and reappearing in another. Each clue deepened the paradox. The universe seemed to demand the presence of hidden matter. Galaxies required it. The microwave background hinted at it. Neutrino anomalies whispered of it. And yet, every attempt to capture it directly ended in silence. Detectors buried deep underground, shielded from cosmic rays, waited for collisions with invisible particles, and almost always found nothing. The more carefully scientists searched, the more the absence itself became a signal. It was as though the cosmos were guarding its secret. An entire world may exist alongside our own, composed of matter we cannot touch, chemistry we cannot trace, structures we cannot see. It may swirl in the same galaxies, occupy the same space, share the same history, yet remain forever hidden, detectable only through the subtle tug of its gravity. This deepened not only the scientific puzzle, but the philosophical one. For, if such a mirror sector exists, it is not merely an addition to our universe, it is a doubling of it, a twin reality, bound to ours, yet inaccessible, shaping our fate without ever revealing its face. And so the investigation pressed forward, guided not by certainty, but by necessity. The missing mass of the cosmos demanded explanation. And if that explanation lay in the shadows of a mirror world, then the boundaries of reality itself would need to be redrawn. Chapter 4: Escalation. Mystery deepens. By the late 20th century, the silence of the cosmos had become deafening. Astronomers, armed with ever more powerful telescopes and satellites, mapped the heavens with unprecedented clarity, and everywhere they looked, the same revelation emerged. The universe was dominated not by the familiar stars, planets, and galaxies, but by something else, something unseen. The evidence was undeniable. Galaxies rotated too quickly to be held together by their visible stars alone. Clusters of galaxies bent light in arcs too vast to be explained by ordinary matter. And when scientists calculated the total balance sheet of the cosmos, a staggering truth appeared. 85% of the universe's matter was invisible. Only a thin fraction, the 5% of matter we know, belonged to the atoms of our bodies, the burning cores of stars, the dust of galaxies. The rest, the overwhelming majority, remained hidden. It was here that the idea of mirror matter surged back with renewed force. If an unseen sector of particles shadowed our own, then its collective weight could explain the missing mass. Perhaps galaxies were not only systems of ordinary stars, but also veils of mirrored stars, cloaked in invisibility, binding the cosmos with their gravity. Perhaps the great cosmic structures mapped by astronomers were only the luminous embroidery stitched on a vast fabric of unseen worlds. But the deepening mystery cut sharper when experiments tried to catch this shadow directly. Detectors were built in abandoned mines and buried beneath mountains, shielded from cosmic rays, waiting for a rare collision between dark matter and ordinary atoms. They were cooled to near absolute zero, tuned to detect the faintest whisper of energy, yet time and again the silence persisted. The instruments recorded nothing. It was as if the universe was hiding its secret behind a wall too perfect to breach. For some, this silence suggested that dark matter was not conventional at all, not a new kind of particle within the standard model, but something far stranger, a mirror sector that barely touched our world. If so, then the absence was itself a clue, the stillness a signature of its ghostly nature. And then came the most staggering speculation of all: symmetry, not only of matter, but of time itself. If the Big Bang was the birth of all things, could it have produced not one universe, but two, joined back to back, like reflections in an infinite hall of mirrors? One universe dominated by matter, the other by antimatter. One flowing forward in time, the other retreating backward, each the other's echo. The symmetry was almost unbearable in its beauty. In one direction, entropy increases, disorder grows, stars burn, galaxies drift apart, and time advances. In the other, entropy may flow in reverse, stars unburn, galaxies contract, order builds, and what is our distant past might be their future. A cosmic palindrome written in the arrows of time. To contemplate such a vision was to step beyond physics into philosophy. If time itself has a mirror, then causality may not be absolute, and existence itself may be doubled. The familiar rhythm of past, present, and future might only belong to one half of reality, while in its twin, the rhythm beats in reverse. The escalation was profound. What began as a solution to a broken symmetry in particle physics had grown into a reimagining of the universe itself. Not merely the question of unseen matter, but of mirrored universes, mirrored time, mirrored reality. And with this came an unsettling realization. If the mirror world exists, then what we call the cosmos, the totality of being may be only half the story. The other half, unseen and untouched, may still be out there, moving through its own history, its own direction of time. A second reality, as vast and ancient as our own, whispering through gravity, hidden in silence, waiting for us to see beyond the surface of the visible world. Chapter 5: Theories and Speculations. As the search deepened, the mirror universe moved from a curiosity of symmetry to a canvas for bold speculation. The more the visible cosmos resisted explanation, the more theorists turned to what might exist beyond its surface. Mathematics opened doors, philosophy widened them further. One of the most developed visions became known as the mirror-matter hypothesis. In this model, nature is not incomplete, it is doubled. For every particle in the standard model, the electron, quark, photon, there exists a twin, identical in mass and obeying the same equations, but confined to its own invisible sector. The mirror particles form their own atoms, their own molecules, their own chemistry. A shadow periodic table could unfold in that hidden realm, as rich and intricate as our own. The difference lies only in the separation. They do not shine into our detectors, nor collide with our matter, except through the faintest tug of gravity. If real, mirror matter is not exotic at all. It is ordinary matter, but in another universe, this idea finds its grander stage in twin universe cosmology. Here, the Big Bang is not seen as a singular eruption creating one cosmos, but as a double birth, twin expansions, interlocked like dancers, moving apart, each carrying half the symmetry of the original state. We inhabit one, the other, invisible, races outward alongside us. Together, they balance what was once whole. From this vision emerged an even more daring theory, the CPT symmetric universe. In the language of physics, CPT symmetry combines three operations: charge, parity, and time reversal. The laws of nature, when subjected to all three at once, remain perfectly balanced. Neil Turok and his collaborators suggested that this symmetry may extend to the cosmos itself. Our universe, expanding forward in time from the Big Bang, may be balanced by a mirror universe expanding backward in time on the other side. What we call before the Big Bang could be a reflected cosmos running in reverse, its arrow of time opposed to ours. To them, our future would look like their past, and their past like our future. The Big Bang, in this vision, is not a beginning, but a point of perfect reflection. If this is true, then particles like neutrinos may serve as messengers between the two worlds. Experiments have long suggested that neutrinos oscillate between states we can see and states we cannot. Some physicists propose the existence of sterile neutrinos, particles that ignore the known forces of nature. Could these be the portals, slipping silently between our universe and its mirror, carrying with them the proof of another realm? If so, then every neutrino streaming through space, birthed in the heart of stars or in the earliest seconds of the cosmos, may be a traveler between worlds. Even dark energy, the mysterious driver of cosmic acceleration, has been drawn into speculation. Some have imagined it not as a property of empty space, but as the invisible handshake between universes, a subtle pull or push exerted across the mirror divide. Perhaps our universe races outward, not simply because of what lies within, but because of the tension of what lies beside it. Beyond these theories lies speculation more philosophical than physical. If matter organizes itself in the mirror sector, as it does here, then the structures we see, galaxies, stars, planets, may have their reflections. There could be mirror galaxies, swirling silently alongside our own, mirror stars, burning, unseen. Even mirror life evolved in alien isolation, conscious in ways we cannot fathom. And if consciousness itself arises from the patterns of matter, then could there be mirror minds, beings who look outward into their night sky and wonder if they, too, are alone? But here the imagination encounters its greatest question. Would they resemble us? Or would the mirror be stranger than reflection? Would their physics invert their biology, their chemistry, their very sense of existence? Would what we call left, they call right? Would their stars rise as ours set? Would their time flow in the opposite direction, making their lives unfold in reverse? These speculations linger on the threshold between science and philosophy. They are not proven, nor perhaps provable, but they remind us of the scale of the unknown. The mirror universe, if it exists, is not merely a hidden part of reality. It is reality doubled, a second cosmos, as vast as our own, whispering through gravity and silence. And in contemplating it, humanity confronts not only the mystery of the universe, but the mystery of itself. Are we singular, or are we mirrored? Is our cosmos the whole, or is it only the visible half of a greater unseen reflection? Chapter 6: Scientific Tools and Ongoing Testing. To chase the unseen is to demand instruments of extraordinary subtlety. If the mirror universe exists, it will not reveal itself easily. Its matter does not glow. Its stars do not shine. Its particles slip like shadows through detectors. And so, science has been forced to sharpen its tools, to build machines capable of hearing the faintest whispers from the abyss. The search begins with neutrinos, those ghost-like messengers that pass through planets and stars with almost no resistance. Vast detectors deep beneath mountains, buried under Antarctic ice, sunk into old mines, now wait for their fleeting touch. They watch for oscillations, the transformations of neutrinos from one kind into another. But more importantly, they search for something stranger still, the vanishing act into sterile or mirror neutrinos. If such oscillations are found, it would be the first concrete evidence of a hidden sector, a signal that our universe is not alone at the frontiers of high-energy physics. The Large Hadron Collider has joined the hunt. Its proton collisions, reaching energies once unimaginable, can reveal cracks in the Standard Model among the jets of particles and flashes of energy. Physicists look for missing momentum, unexplained gaps in the balance sheets of matter. These absences could signal the escape of hidden sector particles, evidence that mirror matter has briefly crossed into our world before vanishing again beyond the laboratory. Astronomers turn their eyes skyward. They search for faint microlensing events, sudden brightening of distant stars when an unseen mass passes in front of them. Ordinary dark objects, like black holes or rogue planets, can produce such effects. But so, perhaps, could compact mirror stars, entire suns of the hidden universe, whose light never reaches us, yet whose gravity bends the light of others. Every flicker recorded in these surveys is a potential whisper from the mirror realm. The cosmic microwave background, too, becomes a testing ground. Its faint ripples are the fossil record of the infant universe, a snapshot of symmetry written in light. Scientists sift through its statistical patterns, searching for signatures of CPT symmetry, echoes that might reveal whether our universe is balanced by a time-reversed twin. Each fluctuation is measured with exquisite precision, as though the cosmos itself has hidden clues in its first light, and the future promises sharper tools still. Dark matter detectors are being refined to levels once thought impossible, cooled to temperatures colder than space itself, shielded from every stray signal but the one they seek. Quantum gravity experiments may one day probe interactions so faint they border on the philosophical, testing the very limits of matter and spacetime. New space telescopes, more sensitive than any before, are preparing to map cosmic evolution with a clarity that could expose the fingerprints of hidden universes. In this pursuit lies a delicate balance between speculation and evidence, between theory and observation. Science is not built on imagination alone, nor on data alone, but on the bridge between them. Theories open the door to possibilities. Instruments decide which of those possibilities belong to reality. The mirror universe, if it exists, will not yield easily. It hides in gravity, in silence, in shadows that refuse to be touched. But history shows that the universe rarely withholds its secrets forever. Every revolution in science, from atoms to galaxies, from relativity to quantum mechanics, began with whispers, anomalies, hints that refused to vanish. Perhaps the mirror universe will be no different, and so the detectors remain vigilant. The telescopes sweep the sky. The colliders spark collisions brighter than stars. Each is an ear pressed against the silence, waiting for a signal that could redraw the map of reality. For if the mirror world is real, then every unanswered question about dark matter, about time, about symmetry itself, may one day find its answer in the hidden half of the cosmos. Chapter 7: Philosophical Reflection, Emotional Close. The universe has always been a mirror. From the earliest myths, humanity has seen the night sky as a reflection of its own questions, its own fragile existence. Every star becomes a spark of hope. Every void, a shadow of uncertainty. And in the modern age, as telescopes reach deeper into the fabric of space-time, the mirror seems to shift, not simply reflecting us back, but perhaps revealing something else, a hidden symmetry, a twin reality, distorted across a cosmic glass, too vast for eyes to truly hold. The mirror beyond the sky in the language of physics. Symmetry is no mere metaphor. It is the grammar of nature. The laws of motion are symmetric in spaceshift, the stage of the universe, one direction or another, and the play unfolds the same. They are symmetric in time roll, the equations backward, and they still hold their form. Even charge and spin, the unseen qualities of subatomic particles, fall into patterns of balance, as though reality itself refuses imbalance. Yet, in the mid-20th century, experiments at Brookhaven and later discoveries in particle physics revealed something unsettling. Mirror symmetry, parity, was not perfect. The weak nuclear force, responsible for radioactive decay, favored left over right. Nature, in its smallest scales, was biased. A mirror image particle would not behave the same as its twin. This asymmetry shook physics, but it also gave birth to an idea. If one universe could lean left, perhaps another leans right. If our reality is imbalanced, perhaps a mirrored cosmos exists to restore the balance. Thus was born the hypothesis of a mirror world, not science fiction, but a serious speculation in theoretical physics. Hidden particles, shadow matter, a dark reflection of all we see, invisible because it does not interact with light, yet detectable, perhaps, through the faint tug of gravity, or through the ghostly whisper of dark matter, halos surrounding galaxies, bound to a reflection. If such a mirror universe exists, then our cosmos is not alone. It is paired forever with a shadow it cannot touch. Like twins separated at birth, each grows according to its own laws, yet each is incomplete without the other. Perhaps dark matter, the unseen scaffold that holds galaxies in place, is nothing more than the gravity of this reflection pressing against our world. Perhaps the cosmic web, stretching across billions of light years, is not only the architecture of our universe, but also the fingerprint of another, woven invisibly through the same fabric of space and time. And if this is true, then loneliness itself may be an illusion. Our universe is not solitary, but forever bound to its unseen partner. Two dancers moving in silence, their steps mirrored across a floor made of infinity. The meaning of the mirror for humanity. Such a possibility reaches beyond physics. If reality itself is doubled, then meaning expands beyond comprehension. To ask where we come from is no longer a single question. The Big Bang itself may not have been a solitary event, but a symmetry, two flames lit in opposite directions, one expanding forward in timers, the other receding backward into what, for us, is the past. Cosmologists such as Sean Carroll and Alan Guth have explored these possibilities, suggesting that what we call the Big Bang may be less a beginning than a boundary, a moment of symmetry in which two universes, like twin ripples, emerged from a single disturbance in the quantum fabric. If so, then existence itself is relational. We are not only products of our own universe, but of the mirrored one as well. Every atom here may have its shadow counterpart there. Every moment of time here may be reversed, echoed, or rewritten there. This does not mean there is another version of every human, nor that fate is duplicated. The reflection is not identical. It is distorted, refracted, altered by the angles of symmetry. Like a face glimpsed in dark water, it is familiar, yet strange, recognizable, yet unreachable. The human condition in a mirrored cosmos for philosophy, the implications are profound. If we are not singular, then identity itself is challenged. What does it mean to be unique if the universe is never alone? If reality is mirrored, then destiny becomes a question without boundaries. Do we move toward an end that is ours alone, or one shared with a shadow we cannot perceive? If our universe collapses, does its reflection collapse as well? If ours expands into cold silence, does the other awaken with fire? These questions echo through human thought like the resonance of a struck bell. We build meaning on the assumption of isolation, that there is only this, only here, only now. But if another world, silent and unseen, moves with us, then meaning itself must expand. Perhaps we are not the only authors of our story. Perhaps we are only one half of a larger symmetry, our role incomplete without the other. The Big Bang, as twin flame to picture this symmetry, one must return to the beginning, not as a single spark, but as two flames struck in opposite directions. The universe we inhabit, rushing forward into entropy, and its partner, falling backward into order. This is not mere metaphor. Some cosmologists argue that the arrow of time, the direction in which entropy grows, could run oppositely in another universe. What we call the past might be the future there. Our decay is their becoming. Our silence is their birth song. If so, then the cosmos is not simply expanding, it is balancing two realities joined in symmetry, ensuring that the total story of existence remains whole. Haunting questions, so the reflection lingers, not in glass or water, but in the very laws of physics, in the silent pull of gravity, in the whisper of symmetry, broken yet remembered. The questions remain, unresolved yet inescapable. If they exist, do they wonder about us? Do they gaze at their skies, searching for patterns that suggest a hidden twin? Do they write equations, finding cracks in their physics that hint at our world? Are we their reflection as much as they are ours? Is every question we ask, every equation we solve, echoed by them in reverse? And if, one day, one universe falls silent, its stars burned out, its galaxies dissolved into darkness, does the mirror shatter? Or does the reflection remain, forever holding the image of a world that once was? The final image, the end, the mirror, may be all we have, not as certainty, but as possibility. A reminder that reality is larger than comprehension, that every answer opens into deeper mystery. The universe, then, is not a solitary flame, but a pair of lights. Two sparks struck in the darkness, burning in opposite directions, yet bound together, forever illuminating the same infinite glass. And so humanity stands at the edge of the mirror, peering outward, only to find itself reflected back, a reflection distorted, haunting, and perhaps eternal.